Hey, so I just wanted to do some of the problems from our word problem packet that I handed out in class on Tuesday. This is the one where I mentioned that there were a lot of problems in it that were similar to ones that we did when we were just doing one variable, and we're going to look at them again with two variables. And the one that we started was this mixture problem in problem 10, and this is where we got in class on Tuesday. So we had defined our variables. X was the amount of 12% acid solution, Y is the amount of 20% acid solution. We had set up our table just as we normally did when we did mixture problems, the only difference being instead of having a single variable that we used to tell how much of the 12% acid solution we needed and how much of the 20% acid solution, we gave them two separate names. Again, before we probably would have done something like X and 100 minus X instead of X and Y. All right, we set up our two equations. We knew that the total amount of 12% and 20% had to be 100 gallons as per the instructions in the problem. And then the second equation that we set up was the one that we normally did. Right? Usually we only had this left column giving us the equation. So we have 0.12x plus 0.2y equals 18. And I believe that in class we were just at the point where we were getting ready to multiply both sides by 100. So let's do that. So the top row is going to stay x plus y equals 100, and the bottom one's going to become 100 times 0.12 just gives us 12x. 100 times 0.2y is going to give us 20y, and 100 times 18 is going to give us 1800. All right, we are back at the point that we would be on page 69 in our workbook, where we just have two equations, x with two variables. The x and y are together on one side, the constant is alone on the other side. And what we're going to do is we're going to select a variable to get rid of. So normally in class I would ask you to pick, but now I'm going to get to do it. And I'm going to choose x only because the number is smaller. So let's go through and multiply the top row by negative 12. And then when we do that, we get negative 12x minus 12y equals negative 1200. And the bottom one here, we still stay 12x plus 20y equals 1800. Right, we're going to combine the terms here. The negative 12x and the 12x will cancel. The negative 12y and the 20y will give us 8y. And the 1800 minus 1200 is going to give us 600. All right, next, divide both sides by 8. The 8's right here are going to cancel. And so then we just have to figure out what 600 divided by 8 is. All right. 600 divided by 8 gives us y is equal to 75. All right, so that tells us that we should be using 75 gallons of the 20% solution. Again, back here, that's what y stood for. But now we need to find out what x is. All right, so think about what we would have done in class. Hopefully you said you go back to one of the two original equations. The easier one by far is this one right here. So I'm going to take and rewrite this as x plus, instead of y in here, I'm going to write the 75 that we just found and say that has to equal 100. All right, and when I solve that, I subtract 75 from both sides, I get x equals 25. All right, and these two do add up to 100, which is awesome because that's what we need, 100 gallons of the 18% solution. Again, it's not a bad idea to go back and plug them into the original equations, not the one that we used, but this one down here. Or if you feel confident that you multiplied by 100 correctly, you certainly could go put it in here. That might be a little easier so you're not dealing with decimals. But just for the sake of the video, I'm not going to do that. And so what we'll just write here is the lab needs 12. It needs 25 gallons of the 12% solution and 75 gallons of the 20% solution. All right. Okay. The other problem I want to look at on this page is number 12. Again, because we looked at a problem similar to this earlier, so I feel like this would be a good one to repeat. Sophia's school took a field trip. A total of 21 vehicles were needed for the trip. Some students took the bus and some students carpooled. There were 30 people on each bus and 4 people in each car. 318 people altogether attended the trip. How many buses and cars were needed for the trip? All right, so again, we would read the question here. How many buses and cars were needed for the trip? So let's let X equal number of buses. All right, before I write let Y equal number of cars, which is where I'm heading, remember in a previous problem when we did this, we knew that there were 21 vehicles altogether. So if X was the number of buses, what we would have done when we were restricted to a single variable is we would have said that 21 minus X was the number of cars. But now we're going to give it its own variable, so Y equals the number of cars. All right. And as we discussed in class on Tuesday, we're looking for totals of things, all right? Because those totals are going to tell us what the equations have to be representing. So we know that there's a total of 21 vehicles, all right? So this is going to have to be something plus something equals 21 vehicles. And we also know that there are 318 people altogether. All right, so this has to be people plus people equals people, and vehicle plus vehicle equals vehicle. All right, so then we have to think, all right, what equation could I write that tells me the total number of vehicles? I'm pausing because I want you to think about this. Okay, hopefully you said that X plus Y, the number of buses plus the number of cars, should give us 21. All right, that's the total number of vehicles, and each of these represents a number of vehicles. Okay, now the total number of people, again, the only variables we have to work with here are the number of buses and the number of cars. So let's go through and look to see how we could get number of people out of that. All right, so we have 30 people on each bus and 4 people in each car. Right, so if I know that there are X buses and there are 30 people on each bus, how can we say the number of people that were on the buses altogether? Right, hopefully you're saying 30X, that each bus carries 30 people, so it's 30 times the number of buses that we have. Right, and then we could do the same thing here for cars, 4 times Y. And then that gives us our system right here, all right? Something about the number of vehicles, something about the number of people, and those are our equations. All right, so now we're at the point where we get to select a variable to get rid of. I'm going to choose Y. All right, again, only because the numbers are smaller. Really, that's the only reason at this point, because it's not like one of these signs is positive and the other is negative, that might give it the edge. Same thing here. So I'm going to just choose Y. And that means I'm going to multiply the top row by -4. The 4 because I want to make sure that this 1 that's in front of the Y becomes a 4 to match this. And then the negative because I want to make sure their signs are the opposite. Okay, so when I do that, I get -4x minus 4y equals -84. The bottom row stays the same. So 30x plus 4y equals 318. Right, the y's cancel out here, and I end up with 26x equals, let's see, 318 minus 84, that's 431. All right, so I get 234. All right, so now I need to divide both sides by 26. I have no idea how many times that is, so I'm just going to kind of estimate here. 26 is closer to 30 than it is to 20. So I'm going to kind of estimate that to be 30, and then here I'm going to go a little bit down. Since I went up here, let me go down. So let's say maybe 210. Only reason I'm doing that is because I want two numbers that are easy to divide, right? So I'm going a little bit too high with the 26 and a little too low with the 234. I get an estimate of 7, but let's try that out. So if I do, let me just do it right here. 26 goes into 234 7 times. I don't think that's going to be right, because the other thing I have to pay attention to is there shouldn't be any remainder, and 6 times 7 is not going to give me a 4 on the end. But let's do it and see how far apart we are. 6 times 7 is 42. Put down the 2, carry the 4. 7 times 2 is 14, plus 4 more is 18. Dang, we were pretty far off. We can definitely fit 2 more in there. So let's go with 9. All right, 9 times 6 is 54. Put down the 4, carry the 5. 9 times 2 is 18, plus 5 is 23. All right, so that tells us that x equals 9. All right, in other words, there were 9 buses. Now we need to figure out how many cars there were. So we're going to go back to the original set of equations and choose one of them to put the 9 in. Again, I hope it's obvious that you would want to choose the first one just because it is a simpler equation. So not x, we're replacing that. We're going to say 9 plus y equals 21. I'm going to subtract y from both sides, and so I end up with y equals 12. All right, and so I would say there were 9 buses and 12 cars on the field trip. All right, I'm going to pause and move to another spot that maybe has better lighting so that you don't see all these shadows on the paper. So I'll be right back. Okay, hopefully that's better. All right, so I want to flip back to the page before, and I want to look at problem number 8. Again, this is because we looked at a ton of coin problems, and this is another coin problem right here. So Dante has 27 coins that are all dimes and quarters. The value of the coins is $4.35. How many dimes and how many quarters does Dante have? So again, previously we would have said something like let x equal the number of dimes. And then instead of writing y equals the number of quarters, we would have said, okay, well, if he's got a total of 27 coins and I've already used up x of them for the dimes, then I would have 27 minus x for the quarters. But because we now know systems of equations, we're going to say, no, I'm going to write a second equation. So y equals the number of quarters. Sorry, not a number, it's not a second equation, a second variable. Okay. So as with the previous problem, we're going to go through and we're going to say what are the totals that they're talking about, because the totals are going to tell us what the equations have to be about. So it tells us he has a total of 27 coins. So one of the two equations is going to have to be about the number of coins. And again, it's going to be some number of coins plus some other number of coins give us this total. And then the second total they have is the value, right? That altogether the coins are worth $4.35, but again, I'm going to say 435 cents. Right, so this is the amount of money. Right, so I'm going to have two amounts right here that I add to get the 435 cents. All right, so then how could we use our variables and what we know about coins to come up with this first equation right here? So if I've got 27 coins altogether, how could I write that? All right, hopefully you said that I would take the number of dimes plus the number of quarters, and that would tell me the number of coins altogether. All right, for the second equation, I've got 435 cents. I know how many dimes I have. I also know that each dime is worth 10 cents. All right, so let's say I have 7 dimes, and since dimes are worth 10 cents, then I would have 70 cents, or the number of dimes times the value of the dime. So here I'm going to write that it's 10, the value of the dimes, times the number of dimes. And then the second one, we would do 25 times y, the value of the quarter times the number of quarters. All right, how about you pause the video at this point, and I just want you to go ahead and solve this system of equations on your own. So go through the steps of deciding which variable to eliminate, multiplying one row by something to eliminate that variable, and so forth. And then when you're done, turn the video back on, and then I'll walk through the rest of it with you, just so that you can check your work. All right, so turn it off and go ahead and finish this problem on your own. Okay, I'm choosing to eliminate the x. I'm hoping that you chose that one, but you will still end up with the same answer. It just won't be as easy to find your errors if you made any. All right, so I'm going to eliminate the x. That means I'm going to multiply this top row through by 10 to make sure their coefficients are the same, but negative to make sure that their signs are the opposite. All right, when I do that, I get negative 10x minus 10y equals negative 270. And in the bottom row, it stays the same, 10x plus 25y equals 435. When I combine these things here, these cancel out, and I get 15y equals 435 minus 270. That's 0. 160. Let me just make sure that I did that correctly. 5 minus 0, 13 minus 7 is 6, and 3 minus 2 is 1. Okay, so then how many times does 15 go into 160? Whoops, I knew something seemed wrong. I was going to say 5 minus 0 isn't 0, it's 5. I'm sure you were all screaming that. Mrs. Taylor, that's wrong. Okay, 15 goes into 165. That's better. That is 11 times. All right, plug it back into the original equation here. So I get x plus 11 equals 27. Subtract 11 from both sides, and you get x equals 16. All right, so Dante had 16 dimes and 11 quarters. And this would be an easy way to check that. I know that 16 and 11 add up to 27. All right, that satisfies the first requirement here. And if I do 16 times 10 cents, I get $1.60. And if I do 11 times 25, let's see, 4 groups of 25 is 100. So then another 4 is a second 200. That brings us up to 8 quarters, and then 3 more. That would be $2.75. So if I do $2.75 plus $1.60, that would give me, whoops, what's it with me? 5 and 0 today. All right, that gives us a 13, carry the 1, and that gives me the 4. So that would be a nice, easy way to check it, is to just add these two together to make sure you get the 27 coins, and then calculate the value of the 16 dimes and the 11 quarters, and you do get the $4.35. Okay, that's all I'm going to ask us to do on this packet today. I just want to show you that the ones that we've done in the past we can do with 2 variables, even though in the past we've done them with 1. Okay, so now I would like you to turn to page 75 in your workbook. All right, this is the one I was asking you about in class on Tuesday. And in fact, you have problems 1 and 2 done at least from when Sam was visiting in my place. So let's take a look. Let's skip to number 4 for a second. We'll come back to, we'll take a look at 3 and 6 in just a second. But again, if you remember, there's a couple different ways to do this. For right now, since I'm not sure what everybody's background is, I'm going to assume that you have not talked about anything other than plotting points. But again, we will work on other strategies, but for right now, let's just do that. And again, when the coefficient of the x, the thing you're going to be multiplying by x, is a whole number, you can pick whatever numbers you want. But when it's a fraction like 7/2 that you did before, or when it's a fraction like this, 6/5, let's be smart about the numbers that we choose. Instead of choosing the typical -2, -1, 0, 1, 2, and ending up with fractional amounts for every single one of these that are not 0, let's instead pick something that when I multiply it by 6/5, the fraction will go away. All right, so I'm going to pick something that has a factor of 5 in it, so when I multiply by 6/5, they cancel. So I'm going to choose to do -5, 0, and +5. All right, so when I multiply 6/5 by -5, I'm going to do this work here, 6/5 times -5 plus 1. Right, again, if I imagine that -5 is -5/1, these 5's along the diagonal there can cancel out. We can reduce before we even multiply. 5 goes into 5 once, 5 goes into -5 -1 time. So this would give me -6 plus 1. -6 plus 1 is -5. Right, we do the same thing with 0. We do -6/5 times 0 plus 1. Oops, starting to realize I was probably getting off the screen there. -6/5 times 0 is just 0, and plus 1 is 1. And then we'll do it again for the last one. Not -6/5, just 6/5. All right, so the last one is 6/5 times 5 plus 1. The 5's here again will cancel, leaving us with just 1's. So it's 6 times 1 is 6, plus 1 is 7. All right, let's plot them. At -5, again, we start from the origin, and we go 5 units to the left, and then from there it tells us to go down 5, so we're going to plot a point right here. Right, here we go back to the origin. It says do not go left or right at all. Move 0 in the x direction, but 1 in the y direction. Right, and then we're going to have to fudge this one a little bit because we don't have enough room. But at 5, it says to go up to 7. Right now, it only goes up to 6. So just kind of draw where that 7 would be if the y-axis extended a little bit. And then we're going to just connect them. Right, so that's what that linear equation looks like. All right, let's do this one right here, number 5. So again, because of this fraction right here, it makes sense for us to pick values that will cancel out with that 4 in the denominator. So I'm going to choose -4, 0, and 4. Again, 0 just cancels everything out, so that's why we can pick that, and it doesn't have to have a denominator. But the -4 and the +4 will cancel out with that 1/4. If we had more room, we could do -8 and +8, or -12 and +12, but we're stuck in this -6 to 6 interval right here, so that's why I'm just picking those 3. All right, so let's figure out what we get here. So if I do 1/4 times -4, and I add 2 to it, right, again, 4 is a common factor of both. 4 goes into 4 once, and 4 goes into -4 -1 times. So this cluster right here ends up being a -1 plus 2, which gives us 1. Again, we shouldn't even have to put the 0 in to figure that out, because 1/4 times 0 is just 0, and then we add the 2, and we get just 2. Finally, we have 1/4 times 4 plus 2. These will cancel out, so we just end up with a 1 right here, plus that 2 gives us a 3. All right, well, let's plot them. This says from the origin, go -4, right, go 4 units to the left or to -4, and then go up to 1. This says go no amount left or right, but go up 2. And then this last one says go to positive 4 on the x-axis and 3 on the y-axis. And then connect the dots. Sorry, that's our heater that's kicking on and off, that's making all that noise. Okay, just two things I want you to notice, because we're going to talk about this more as we go on. But notice how this crosses the y-axis. Again, y-x, so this crosses the y-axis at 1, and we had a +1 right here. And then here, this crosses the y-axis at 2, and we have a 2 here. That is no coincidence. In fact, if you look back at your graphs that you did when Sam was with you, you would have found that this one crossed at -2. It also probably went up 1, 2, 3, 4. It probably also was over here was your graph. All right. So that -2 right there, and that -2, and then also this one would have been up at 3, and then this one would have gone down 1, 2, 3, 4, 5, 6. It would have looked something like this. All right. This constant at the end, that number that's just added or subtracted in each case, tells us what the y-intercept is, where it crosses the y-axis, but only in cases where we have the equation where just y is by itself on one side, like these that are on this page. We'll look at other problems where that's not the case, and then that constant doesn't translate as nicely, but when y is by itself and everything is on the other side, that tells us what the y-intercept is. The other thing, it tells us, again, you'll notice that some of these graphs are really steep, especially the two that you did with Sam are very steep. This one's pretty steep. This one's really not steep at all, right? And that steepness comes from this coefficient in front of the x, right? That's called the slope, right? And it tells us the steepness and the direction of the line. So notice these three that were positive were all rising as you go from left to right. Imagine yourself on this line and you're walking and you're going from the left to the right, just like you read a book, always go left to right, and I'm going up, and that's positive. Here, if I put myself to the left of the line and I walk, I'm going up, positive. Same thing with number 1. If I put myself on this line and I walk from the left to the right, I'm going up. This one, as I put myself on the left side of the line and I walk to the right, I'm going down. Notice that's the only one that has a negative slope, right? Or a negative number in front of there. It also tells us how far we rise, in other words, move up or down, to run, how much we move left or right. So from here, I rise up 7, 1, 2, 3, 4, 5, 6, 7, and I run, go to the right, 2. Right, that's where my next point is. When you plotted points, you found that the point 2, 5 was another point on the line. Same thing here. If I start at this point, this tells me to rise 6, go up 6, and run 5, go 5 to the right. So 1, 2, 3, 4, 5, 6. Again, remember that would have been the point 7, but we didn't have space. And then run 5, 1, 2, 3, 4, 5. Same thing here. This tells us to rise 1. So from this point right here, I rise up 1, and I run, go to the right, 4, 1, 2, 3, 4. And that was another point. This one's a little bit different up here because it's not a fraction. So remember that -6 is the same thing as -6 over 1. All right, so this tells us that we are supposed to rise -6. All right, in other words, that means don't go up, go down. So from here, go down 1, 2, 3, 4, 5, 6, and then run 1. All right. So we'll practice with that more as we go through these, but I just wanted to point that out to you so you can start paying attention to it and recognizing that this is going to be our y-intercept, and then this tells us a path to travel to get to any other point on the line. All right. I could have also started down here and done rise 6 and run 5. That would get me to that. Rise 6, run 5. It works from any point you are on the graph. All right, these two right here are weird cases, so let's talk about them. Numbers 3 and 5. Number 3, if we were to try and set up the XY table, this is essentially just saying, I don't care what you do with X, but my only rule is Y has to be -5. right? So if I pick -2, this rule says, I don't care, you've got to pick y as -5. Let's say I pick -1. Okay, fine with me, but y has to be -5. I pick 0. Okay, y has to be -5. I pick 1. Y has to be -5. I pick 2. Y has to be -5. Right? That's their only requirement. It's just that y is equal to -5. Right? So let's plot these. Here we go, -2, -5. Here we go, -1, -5. This says go 0, -5. This says go 1, -5. This says go 2, -5. Notice that they're all still in a line, but that's a horizontal line. All right, and then this last one right here, x equals 5, same thing. Essentially, this is saying you may only choose 5 as your x. So pick 5, and then you get to pick anything you want for y. I can't go -7 because we don't have room. -6. 5, -2. 5, 4. 5, 5. I don't care about the y. There's no requirement about it. It's just the x. The x always has to be 5. All right, so when we do that, that says 5, -6. This says to do 5, -2. This says to do 5, 4. This says to do 5, 5. Right? All of them will be on this line. Right, so these are two unusual cases when we don't have both variables. If we only have a y, again, it means all the y coordinates have to be that value. And what it means is that the line is going to hit the y-axis, all right, because this is a y line, it will hit the y-axis at -5. All right, y equals means that it's going to hit the y-axis, not be parallel to it. It's going to hit the y-axis at that point. All right, same thing here. This one is going to say that it's going to hit the x-axis at +5. So it's going to hit the x-axis, right, and at 5. All right, I'm going to stop right there for a little bit. I'll be right back. Okay, now I need you to be on page 77 in your workbook. All right, so you should just have to flip one more page. All right, I want you to notice the types of problems that are on this page. The directions are still the same. Sketch the graph of each line. But what I want you to notice is that in every problem, well, with the exception of maybe this weird one right here and this weird one right here, that in every problem, y is not by itself like it was in the previous ones. The previous problems, we call them, we say that they're in the form y equals mx plus b. Right, and again, one of the examples that we looked at was y equals 1/4 x plus 2. Right, so y is by itself. The x term has probably some coefficient, and then there's something added or subtracted onto the end here. This is a different form. This is generally written as ax plus by equals c. Right, so this says x and y are together on one side. They might have coefficients, they might not. In this one, y has a coefficient of 1, which is implied, so we don't write it. And then the constant is by itself on the other. So here, y was by itself, x and the constant were together. Here, x and y are together, and the constant is by itself. All right, so there are different ways to graph these. I'm just going to show you one for now, and that is we're just going to take this and transform it back into that because we've gotten fairly comfortable with that. All right, so let's do that for the first one. I want to get y by itself. So I notice that in this particular case, the only problem I have is that this term, the 7x, is on the same side as the y. So I'm going to transpose it, all right, by subtracting 7x from both sides. And again, if you remember our conversation in class the other day, we said it doesn't matter where I put this -7x on this side. I can put it first or I can put it second. I'm going to choose to put it first so it looks more like this. When I move it, I get y equals -7x plus 5. Again, I could have written y equals 5 minus 7x. I could have chose to put it back, but to make it look like this, I'm going to put it in the front, all right? Okay. So now I can graph this in one of two ways. I can say, oh, I know that the y-intercept is going to be 5. All right. And then I can say, oh, this is the slope. It's a -7, which is the same as a -7/1. All right. That tells me to go down from this point, go down 7, and then to the right 1. 1, 2, 3, 4, 5, 6, 7, and down 1, or over 1. And that should be my line. All right, but let's just confirm that with our XY table since this is a new strategy. All right. Again, I don't have a whole lot of room here, so even if I pick something like -2 or +2, that's going to make this pretty big. All right, it's either going to give us -14 or +14. I add 5 to that, I'm definitely off the graph. So I'm just going to stick with -1, 0, and 1. Even -1 is going to be too big. When I put -1 in here, I get -7 times -1. That gives me +7. +7 and 5 is 12. That's too big. We're not going to end up graphing that one. If I plug in 0, -7 times 0, 0, plus 5 is 5. And then I plug 1 in, -7 times +1 gives me -7. -7 plus 5 is -2. Right, and then I would plot them. Well, it just so happens that those are the points that are already on there. Right, 0, 5, and 1, -2. All right, so again, first step is transform the equation into that y equals mx plus b form where y is by itself, everything's over on the other side. And then you can either take advantage of the y-intercept, plot that as one of your points, take advantage of the slope, all right, the instructions on how to get to any other point on the graph, which says to go down 7 and over 1, or you could do the more traditional way that we've been doing, which is just make an XY table. All right, I just want to do one more of these, and then I'm going to set you free to do some practice problems on these. All right, so let's take a look at number 2. Problem number 2, again, it's in that ax plus by equals c. Again, all that means is x and y are together on one side, constant is alone on the other, and I want to get to the point where y is by itself. All right, so in this case, there are two problems. One is that this x term is on the same side as the y term, and the second problem is that 5 is in front of the y. I don't want that. All right, so first thing I'm going to do is I'm going to transpose the x term by subtracting 3x, subtracting 3x. So I get 5y equals -3x minus 5. Again, you could have put the 3x at the minus 3x at the end, but I'm just going to leave it out front so that it looks like my desired equation. And then I have to get rid of that 5, which means I have to divide everything, each term, not just some of them, but all of them, by 5. Here the 5's cancel out. I end up with y equals -3/5 x. And then it just so happens that this becomes a -1. Sometimes that will stay a fraction, and that's less fun. But for here, we've got this. All right, so again, I'm going to use our new strategy, and then I'll go back into our old strategy. Our new strategy says this is where it's going to cross the y-axis. And then this tells me how to move from one point on my graph to the next. So this says go down 3 and to the right 5. 1, 2, 3, 1, 2, 3, 4, 5, and plot it. All right. Now you might say, I think there's going to be a point over here. I would say that you're right. We could say, well, where was it? It had to have been up over here. I would have had to go down 3 and over 5 to get to it. So let me go backwards. Let me go left 5. 1, 2, 3, 4, 5. I'm going to reverse my tracks and go up 3. That should give me another point. All right, so let's just try that. We'll do the x and y. I'm going to choose -5, 0, and 5. Again, I'm choosing 5, multiples of 5, because they'll go into that. -3/5 times -5 minus 1. These will cancel, and I'll just be left with a -1 here. -3 times -1 is +3. +3 minus 1 is 2. All right, again, I go back to this. I plug in 0. -3/5 times 0 is just 0. 0 minus 1 is negative 1. And then the final one is negative 3/5 times 5 minus 1. These cancel out, and I just get negative 3 minus 1 is negative 4. If you go back and you look at this, negative 5, 2, check. We already had that. 0, negative 1, check. 5, negative 4, check. Okay, those are all the ones that we already plotted. Okay, feel free to go back and watch these videos or this video as much as you want. If I went too fast, I'm sorry. Yeah, and I'm just realizing that all this work I did down here, you probably couldn't see. So anyway, all right, let me know if you have any questions. Bye.